Welcome back, guys. All right, I remain Benjamin, as you all know, or you can possibly call me Benzylene, which is up here. All right, we're still on empirical formula, and we have some questions here or some problems here to solve. All right, so now on the board we have a question. It said a 1.5 gram sample of a compound gives 3.23 gram of CO2, 1.58 gram of N2O5, and 1.865 gram H2O. Determine the empirical formula of the compound. All right. So now, solution. Now, 1.5 gram of the sample gave CO2, N2O5, then 1.865. Now look at this question. This question is strictly different from other ones you see, because in some questions the product does not really require if a particular element is in the sample. All right, at the end of this question you will know the compound that is, or the element though, that is not in the sample. All right, for now we have here CO2. So now we have to find the mole of this compound. We know mole is equal to mass over molar mass. Now mole is equal to 3.23 over 44. All right, we have we have 3.23 divided by 44. Then we have a 0.0734 approximately as the mole. Then carbon here is having an atom 1, so if we multiply by 1 it changes nothing. So now let's find the mole of this compound. There is a mole for CO2. Now for N2O5 we have mole is equal to mass over molar mass. Now from here we have the mass of this compound is 1.58 over the molar mass of this compound. We have it as 108. Alright, so we have 1.58. We have it as 0.0146 approximately. Now nitrogen is having an atom here as 2, so we're going to be multiplying the moles for we to get the mole of nitrogen in the compound. So we'll possibly multiply here by 2. All right, let me do it up here. So we have the mole times 2, which is equal to 0.0146 times 2. So we have this as 0.0292 moles. Now that is the mole of nitrogen. Now, okay, we already have another compound here as for water. Then we have for H2O, we have mole equal to mass over molar mass. Do we have the molars 1.865 over mass of water is 18. So we have here as 0.1036 approximately. Then hydrogen is having it 2 here, so we'll possibly multiply by 2. So we have an approximate value of 0.2072 approximately. All right, so now we have the mole of nitrogen, carbon, mole of carbon as 0.0734, then mole of nitrogen as 0.0292, then mole of hydrogen as 0.2072. all right, now we're possibly working on the masses in order to find the masses of each element in the sample. From here we have a 1.5, so we're going to be finding the masses of each of them. Now they are already in moles, so we have to convert all of them to mass for we to know the mass of each element in the sample. All right, so we now have here, remember, mole is equal to mass over molar mass. Then I'm doing this straight for each element. Now carbon, there is, we have the molars 0.0734 is equal to the mass, which is unknown, over molar mass. The mass of carbon is 12, so 12, so cross multiply, we are having its mass as 0.8808 gram. Then this is 1. Then for nitrogen we have mole is equal to, okay, let me just go straight. We have the mole here as 0.0292 equal to mass over molar mass of nitrogen. Nitrogen is 14, so cross multiply, we have its mass as an approximate value of 0.4088. now for for the hydrogen, we should have the mass as, mass will be mole times molar mass, so we have to cross multiply direct. So we have the mole as 0.2072 times the molar mass of hydrogen is 1, so possibly change nothing about it, so we have 0.2072. now we have it in gram and in gram. Now we can add the three of them. If you find out in some calculations you do, when you add them, you have some remaining masses. That should be possibly the remaining element left. For now, if we add these numbers, if the total number gives you 1.5 at the dot, then you know in this question oxygen is not among the sample. All right, let's do some calculation here and know if oxygen is not in the sample. We have 0.88 0.08 plus 0.4088 plus 0.2072. Now we are having a total. The total will equal 0.8808 plus this 0.4088 plus this 0.2072. Now we are having here as 1.4968, which is an approximate value of 1.5 gram. So possibly there's no oxygen in the sample. So now we're going to be having a sample comprising of only carbon, nitrogen and hydrogen. There is no oxygen. All right, since we already know that the sample here is already 1.5, so there's no oxygen, so we're going to be finding empirical formula, as I said, that does not have oxygen. All right, so we're not working on mass, we're working on mole to discover the empirical formula. So we're going to be using the mole and not the mass. So now we have here as carbon, we have here as nitrogen, then we have here as hydrogen. Now what is the mole of carbon here? We have the mole of carbon as 0.0734. Then we also have the mole of nitrogen as 0.0292. Then the mole of hydrogen as 0.2072. Now on the empirical formula, we are dividing each of them with the data that has the least value. Now we have 0.073, 0.0292 and 0.072. The smallest here should be this. So we are dividing each of them with this value. So we have 0.0292, 0.0292, 0.0292. Now let's divide 0.0734 divided by 0.0292. We have here as 2.5. Then here should be possibly 1 because they are equal. And here we have 0.2072 divided by 0.0292. And we have here as 7 approximately. Now, as I said in the last video I made, we don't approximate a value on the empirical formula directly, like you approximate here to 3 direct. It does not work on empirical formula. You have to find a least value, then you're going from the least to the top. That will eliminate the decimal directly. Alright, so the value that will multiply each term here, in order to remove this 2.5 to a whole number, should be 2. So we'll multiply everything here by a 2. So we have 2 times 2.5 is 5. So we have it times 2 times 2. So 2 times 2.5 is 5. 1 times 2 is 2. And 2 times 7 is 14. So now we are having a compound here. So our compound should be possibly C5N2H14 or C5H14N2. Any of these should be the compound. If you can see any of this on your option, you click they can't give you these two. It might either give you this or this, so you click the right option. All right, for now this is the end of empirical formula calculation. So the next chapter we'll be going to should be molecular formula. Don't forget, like the video, subscribe to our YouTube channel, and drop your comments. I remain Benzylene. Thank you.